All right, so the second fundamental theorem of calculus, the chain rule version, tells us that if u and v are functions of x, then this is how we take the derivative and a definite integral at the same time. Now remember, a function of x could be anything, right? It could be a polynomial, it could be cosine of x, it could be, literally any function of x, and that would be any function, right? So it's going to have something that has x in it. It's not going to be a constant necessarily. So the second fundamental theorem of calculus tells us that if we have these two functions of x, and we want to find a definite integral and then the derivative, that this is what we have, right? We take v and we put it in for t, but then we tack on the derivative of v, right? Because we just took the derivative of a function inside of a function, so we need to tack on the chain rule. And then we take u and we put it in for t, but then we tack on the derivative of u, okay? So let's take a look and see what that actually looks like. So I'm going to write this right here at the top for us. So we say, when we want to take the derivative of something from, we'll put, let's see, it is u, yep, u is on bottom, and v is on top, of f of t dt, that equals f of v times v prime minus f of u times u prime. Okay, so this is our second fundamental theorem of calculus with the chain rule. So let's see what it actually looks like. So here's the first one. We're going to do this without integrating, right? We're not going to take this function, go up, and then come back down. We're just going to figure it out with the second fundamental theorem of calculus. So the first thing, let's just define u and v, right? So in this case, 0 is v, right? And x is u. So we can say that it equals f of 0 times 0 prime minus f of x times x prime, right? That's what we have right there, right? If 0 is v and x is u. So what is this, right? Okay, so let's think about this. 0 is a constant, right? 0 is a constant. And this just said take the derivative of 0. What's the derivative of 0? It's 0, right? So if the derivative of a constant is 0, then this entire piece right here becomes 0. Okay, and then we have minus f of x times x prime left. Okay, what is f of x? Well, f of t was 2t minus 3, right? So f of x is going to be 2x minus 3. And then it says times the derivative of the inside function, x prime. Well, what is the derivative of x? The derivative of x is just 1, right? This is the derivative of x would, just be 1. So the derivative of this entire thing is going to be, or the answer to this entire thing is negative 2x minus 3. And notice the negative sign. It's really important because did you see the x is on the bottom here and the 0 is on the top? So we can't just like plug in the x and then be done, because 0 minus this f of x, right? And so a lot of times people will actually, like when they see these limits of integration, they'll flip the limits of integration and then make it negative. There's there's a geometric reason why that works, because integration is really the area under a curve. But truly, you could just set it up like this and it would make sense, right? This minus that. So that's one thing that you want to make sure you don't forget. So that's the answer, negative 2x minus 3. So let's look at the next one. Okay, let's do this without integrating. So let's see, 5 is v, right? And 2 is u. So let's just figure this out. Okay, so f of 5 times 5 prime minus f of 2 times the derivative of 2. Okay, well, what does that equal? Let's see. Well, first we have the derivative of a constant, and the derivative of 5 would be 0. So the derivative of a constant would be 0. So this entire thing becomes 0. And then we have the derivative of another constant. You know, the derivative of 2 is 0. So that becomes 0, and the whole thing equals 0. And remember I talked about that if these two limits are constants, then we end up with 0, right? Because a definite integral is just a number, right? This is just a number, and when we take the derivative of a number, we get 0. Okay, so the definite integral is a number. It's just a constant. And when we take the derivative of that, we just get out 0. But that's where the fundamental theorem of calculus, second fundamental theorem of calculus, kind of shows that for us. All right, let's take a look at this one. So v is x cubed, and u is negative 1. So let's go ahead and figure this one out. So we have f of x cubed times the derivative of x cubed, which is 3x squared, minus f of negative 1 times the derivative of negative 1, which is 0. So we can even, now we don't even need to write that because we're getting pretty good at remembering that that's just 0. Okay, so that whole thing goes to 0. And we end up with f of x cubed times 3x squared. Well, what is f of x cubed? Well, f of t was t squared plus 2t. So f of x cubed, everywhere there's a t, we just put an x cubed, right? So that would be, we're going to put the 3x squared out here just so it's a little easier to remember. And then we've got x cubed. I can never write my 3's small enough. Squared plus 2 times x cubed. And so we'll just go ahead and simplify that just a tiny bit. We're going to have 3x squared times x to the 6th plus 2x cubed. And I think that's simple enough. So that's that whole thing evaluated at those limits of integration. Okay, so let's take a look at the next one. I think I'm going to zoom in a little bit. I'm having a hard time writing in such a small space. Okay, so again, let's see, f of t is t squared plus 2t, right? So 3x is v and 2x is u. So we're going to find f of 3x times the derivative of 3x, which is just 3, minus f of 2x times the derivative of 2x, which is just 2. Okay, that equals, all right, so this one happens to have a function, this one happens to have a function on both limits of integration, so neither one of them end up being 0. So we look at this and we say, okay, so what is f of 3x? Well, f of t was t squared, so we're going to do 3x squared plus 2 times 3x. Now remember, that's just f of 3x, so this whole thing is still multiplied by 3, minus 2 times f of 2x, which is 2x squared plus 2 times 2x. And so we'll just simplify this just a touch, and that would be 9x squared plus 6x there, minus 2 times 4x squared plus 4x. And that's plenty of simplification. So there you go. All right, we got 3.5 minutes for the last two. Let's take a look at this one. All right, so here we have g of x and f of x. Okay, so let's first define our original, like what is our little function in here that we're going to be using. So let's say that this is like big F of t. Okay, that's what this function is, right? Okay, so that's 2t minus 3. Okay, that's the function. So this is v, this is u, so we're just going to go ahead and plug them in, right? So we have big F of v, which is g of x, times the derivative of g of x, which we don't know what the actual derivative is, so we just write it, g prime of x, right? Minus f of x times the derivative of f of x, which is f prime of x. And that is it. Nope, that's not it. Just kidding. Because we do know what big F is. I was like, man, that was easy. I knew there was more. We do know what big F is. Big F is 2t minus 3, right? So we're just going to go ahead and plug in everywhere that we saw. We're going to evaluate this, right? So we're going to say g prime of x, right, times 2g of x minus 3. Okay, so that's that, minus f prime of x times 2f of x minus 3. Everywhere there's a t, we just put an f of x. There we go. All right, let's try this last one. So it says if this integral, if f of x equals that integral, then find f prime. So really, this is just saying exactly what we've been doing, but it just wrote it in a different way. So it said find d dx of 0 to 3x squared of 1 minus t squared to the 10th dt, right? This is literally what we've just been finding. They just wrote it differently because this right here means find the derivative of this thing, right? Find the derivative of this whole thing. Oh, my battery's gonna die and my time's gonna run out. So let's just do this really quick. Okay, so we have f of 3x squared times the derivative of that, which is 6x, minus f of 0 times the derivative of that, which is 0. So in the end, we have f of 3x squared times 6x, which is, everywhere there's a t, we just plug in 3x squared. So we now have 1 minus 3x squared squared to the 10th times 6x. We can simplify that just a tiny bit by saying 1 minus 9x to the 4th to the 10th, and we'll put the 6x out here just to be a nice mathy way, and there you go. Oh, okay, dismiss. All right, there you go. That is the second fundamental theorem of calculus. Woo, the crowd goes wild.